Hi, this session is on right angled triangles test questions. So we'll be covering a few questions that were on your test. So the first question we'll be doing is from section B and question 1B. So with this question, we can see we are going to use Pythagoras, and you may notice we've got unknown variables here, x and x. Don't let that confuse you. All you have to do is apply Pythagoras and then simply simplify and solve. So first state your Pythagoras theorem. So c squared is equal to a squared plus b squared. And now what we also need to do is label our sides. So we know the 8 is our hypotenuse. Then we have side A and side B. It doesn't matter which one's which. Okay, so let's substitute our values into our equation. So 8 is the hypotenuse, which is C. So I'll have 8. And please make sure with this example, with this question, you substitute with brackets. It's very important. So my A is now going to be 2x. I must use brackets when substituting because I'm squaring both the 2 and the x. Plus B, so 2x, and then it's being squared. Okay, and just to recap, if you have something like this in brackets, 2x squared, what it's saying is we have 2x times 2x. And using our algebra skills, we know 2 times 2 is 4. And x times x, add the powers of the same base, we end up with 4x squared. And the other way is using the index law. You just go 2 times the power 1 there and 2 times the power 1 there. So we just square the 2 and square the x. So you should have ended up with 4x squared. And then here, 8 squared is just 64 is equal to, so I'm left with 4x squared plus 4x squared. Okay, and at this stage, we'll still continue to use our algebra skills. So I've got 64 equals, I can see 4x squared and 4x squared are like terms, so I add them. So that becomes 8x squared. The x squared stays the same, I just add the numbers in front. Now at this stage, if you want to just rewrite it, so you have 8x squared equals 64. So x is on this side, you can do that, no problem. And now let's solve for x. So now we're using our equation skills. So my next step is, I want x to be on its own. So the first step is divide by that 8. And divide by 8. So x squared will be equal to 64 divided by 8 is just 8. I'll just continue it here. Now x is still not on its own. That squared is a problem. We know we have to square root it. Oops, the opposite of squared. So we're left with x equal to the square root of 8. Now at this stage, this is our exact answer because there is no number times itself twice to give us 8. So the square root of 8 is actually a third. But the question asks us to round it off to 2 decimal places. So the approximate answer of x will be approximately 2.83. Now, there were no units given, so we just stop there. Now, our next question is from section B, and we're doing question 2B. Now, a lot of students struggled with this question because it was, I guess, tricky at first because you've got a lot of things to consider. Now, before you attempt questions like this, it's important to brainstorm what you have to do and what you can do. Now the question says to find x, and x is just down here. That's the aim of this, to solve x. What is that value? What is that length? Okay, so when brainstorming, we can ask ourselves questions or jot down points like this. Now the first one is, what lengths can we find immediately? Or what lengths can we immediately find? So just looking at this question, I can see that I can maybe find this length here by subtracting 14. Oh, sorry. So this length here is 6 meters. It's the same as the top line there. They're equal lengths. And so I can find this length here by going 14, take away that shorter side, 6, and it leaves me with 8 meters. So I have found this length here, from there to there, just by going 14, take away 6. Okay, so this length here is 6 meters. This one here is 8 meters. Is there anything else I can find quickly without having to use Pythagoras or anything like that. Now, at this stage, I think that's all I can do. So my next thing is, the next stop point says, identify any right angle triangles. So I can see there's a right angle triangle here and also another one there. So I have two right angle triangles, and I may need to use those to work out what this x is. The next point says, label unknown sides using variables. Okay, so let's have a look and see what unknown sides we still have to find, or we may need to find. So here I've got this length, this long line there. One second. So that long side, I might call it B. Okay, so that might be useful. And it belongs to that larger right angle triangle just there. And then there's also another right angle triangle here with the 10 and 6 meters. And that means there's also a side length here, a shorter one, just here. And I might call that, so it's a right angle triangle, I might call that A. Okay, so that belongs to that triangle. Now, there are no other side lengths that I can see that I need to find, or that belong to the right angle triangles. So the next stop point, now are we going to use our knowledge of Pythagoras, trigonometry, or similar triangles? So let's have a look at this question. I can see there are no angles given to me, so I don't think I'll be needing to use trigonometry. I can see right angle triangles, and definitely I'll be using Pythagoras to find B and to find A. In similar triangles, there are no similar triangles here in this diagram that I can see, so I won't be using that. So for this question, Pythagoras is the main tool that I'll be using. And finally, what can be done to find the unknown side the question asks for? So the question is asking us to find here. What is this line here? What is x? To find this length here, from there to there, if I find the length b, which is that longer red line side, and if I find that shorter side a and subtract them, that will leave me with x. So if I can find b and then find a, subtract them, I'll get x. So let's try and do that. If it helps, you can draw the triangles separately that we're focusing on. And I'm trying to find that side there, B. And remember, it's simply that red side there that I've got in the bigger diagram. I'm trying to find B. Okay, so to find B, we have to simply use Pythagoras. So state your theorem, c squared is equal to a squared plus b squared, just to make sure we're on the right track. And now label your sides. So 17 is C, B is just B, and this one can be A then. And now let's substitute our values. So C is 17 squared, which is equal to A squared is 8 plus B, which is just B squared. So B stays the same. Okay, and now all I have to do is solve and find B. Now, if it helps, you can rewrite the equation. So 8 squared plus B squared equals 17 squared, if you prefer the B on this side. And now I have to subtract my 8 squared. So minus 8 squared from both sides. Sorry about that. So we subtracted 8 squared from both sides. So B is on its own. So I'm now left with B squared is equal to, let's evaluate our numbers here. 17 squared is 289 minus 8 squared, which is 64. Subtract those. So B squared is equal to 225. And now we just square root that. And the square root of 225 is, 225 is a perfect square, and it leaves me with 15. So B is 15 meters. So we have found that longer side length there for that triangle. Now we have to continue and find the other side length. Okay, so we need to find A. So I've just redrawn the diagram, and that's a triangle I'm focusing on. And A is that shorter side length there. Okay, so once again, using Pythagoras, label your sides just in case, just so you make sure you don't make a mistake. So 10 is my hypotenuse, so that's going to be C. A is just A, and B can be this other side length. All right, so C squared is equal to A squared plus B squared. So C is 10 So 10 squared is equal to, A is just A plus B, which is 6 squared. Now we can rewrite this. So A squared plus 6 squared is equal to 10 squared. And now let's subtract the 6 squared from both sides. So we're left with A squared is equal to 10 squared minus 6 squared. And that cancels out. So now let's evaluate. So A squared is equal to 100 minus 36. And that leaves us with A squared is equal to 64. Now I can see 64 is a perfect square. So when I square root that, to cancel it out, sorry, it's not working. All right, so A will be equal to the square root of 64. So A will just be equal to 8 or 8 meters. All right, so I have found this length here now. That is, I'll put it in blue, 8 meters. So from there to there, I have 8 meters. Okay, so we haven't finished the question yet. Now that we have found those side lengths, we can now find x. So we can state our final answer. So therefore, we can say, so therefore, the length of x is equal to the larger side, 15, minus the shorter side, 8, will leave us with 7 meters. So x here was 7 meters. Okay, so this was a tricky question, but hopefully just brainstorming what you can find and what you need to do will help you work this out. Okay, our next question is question 4 from section B, and this one involves a parallelogram. Now we have to revise some features of a parallelogram to solve this properly, because it says to find the sizes of the angles of this parallelogram. All right, so the angles, there are 4 angles we can see. There's one here where A is, B, C, and D. So we have to find all those 4 angles. That's what the question's asking us. And features of a parallelogram include this: opposite side lengths and angles are equal. So what that means is, if we were focusing on the side length, these side lengths here are opposite and they're equal, as well as these 2 side lengths. But it also, what's important is the angles that are opposite to each other are equal. So angle A here is opposite angle C. They are equal. And the angle here with D is opposite B, and they are equal. Okay, so angle A is equal to angle C, if we just call them that. And angle B is equal to angle D because they are opposite. That's a feature of a parallelogram, and that's really important to know. And the second point that's important to know for this question is angles side by side, or we can say adjacent, add to 180, it's supposed to be degrees. So what that means is, side by side is saying, for example, D and C are side by side, and that means D and C, if we add D and C, they should add to 180 degrees. And the same with A and B. A and B, A plus B, should add to 180 degrees. And of course, you can do the same thing for A and D, and B and C. They will also, so A and D will add to 180, as well as B and C will add to 180. So knowing that, we can find all of these angles. The other important thing to look at, so we've done those points, is we're trying to find an angle. And we might have to use trigonometry for this. Now we can see we've got a right angle here. There's a right angle just there. Okay, the right angle is put on this side, but we know that it's also a right angle in there as well. So there's a triangle here we can focus on. It's a right angle triangle. I am trying to find this angle here, the unknown angle there. So let's start that. Okay, so I have just drawn the triangle separately from my parallelogram, and I'm going to try and find this angle here. So I'll label it in there. That's the unknown angle. The question didn't show us that angle, but they assume that we know there's an angle there that we have to find. Okay, so to find this angle, I will have to use trigonometry. I've got two side lengths given to me. Let's label our sides. So I've got opposite here. I've got the hypotenuse there. And I'm going to be using those two. Now, which one out of our trigonometric ratios has O and H? If it helps, please write this down. So, ka and toa. We can see the one with O and H is sine. So let's write the formula. Sine and the angle is equal to opposite divided by hypotenuse, or over hypotenuse. Now let's fill in what we have. We are trying to find this angle. So no number we put there. That's the unknown variable. For example, we can call it x. O is 6 meters. Just write 6 and over hypotenuse, which is 8. You can put your units in later, so we have less variables and things. Okay, now this part we have to use our knowledge on the inverse of sine. So we just write the angle now by itself. We're trying to find that angle is equal to, we write that sine with that -1, which we know means inverse. And in brackets, we have 6 divided by 8. Now, please enter this into your calculators, and we get the angle into our calculator. And you should get 48.59, I think. And it goes on. The question asks us to find it to the nearest degree. Always check and see what the question asks you to do for your final answer. So the angle is approximately to the nearest degree. Well, the number after the decimal is 5. So if it's 5 or more, you round up. So 8 becomes a 9. So we get 49 degrees. So it's approximately 49 degrees. So this angle here is 49 degrees. And now that we have found one angle, we can actually find every other angle in that parallelogram. So I'll just draw it again. Okay, so we have found this angle down here to be 49 degrees. All right, so using our knowledge on parallelograms, opposite angles are equal. So the opposite angle for D here is now B, so that's 49 degrees. So I know straight away that's 49 degrees. I also know that angles side by side have to add up to 180 degrees. So to work out, for example, this angle here, I will just go, okay, what is 180? Take away 49 degrees. That leaves me with 131 degrees. So that means the angle here is 131 degrees. And last of all, its opposite angle is over here, where A is, and that's also 131 degrees. And we're done. If you wanted to, you could have just written it like this. If each angle is labeled A, B, C, and D, you could just go A is equal to 131 degrees, B, 49, C is equal to 131 degrees, and D is 49 degrees. Just to state your unknown angles. But that's it. So this one was tricky because you may have forgotten the properties of a parallelogram. But once you find one angle in a parallelogram, you can find all the others just by doing this. Now we will continue with our next question, which is from section C, and these were the extended response questions. So the first question says, Miss Kellyanne is standing at the top of a 95-meter cliff. She spots a boat out at sea at an angle of depression of 12 degrees. Draw a diagram of the situation, labeling the information given above. Okay, so when drawing, let's draw our diagram. So before drawing a diagram, we'll just go through these few points. When drawing a diagram, draw a simple diagram. Don't make it too complicated. That represents a problem, and use lines. It makes it easier. Label the given lengths. So if there's any measurements given in the question, label that. Locate the right angle triangle. In your diagram, when we're working with Pythagoras or trigonometry, we have to have a right angle triangle somewhere to work with. So locate that. And then label the length or angle or whatever it is you're trying to find. So you can see it clearly. I am trying to find this particular thing. Okay, so I am going to draw my cliff, and I'll just use a line there. Okay, it can be on that side. And then it says, so she's standing on top. So just put a little circle right on top of that line to say that she's standing on top. We assume she's right on the top there. Okay, she spots a boat out at sea at an angle of depression of 12 degrees. So angle of depression means she's looking down, or the boat's below her. Now, we'll do the boat approximately over here, just so we have some space to draw a triangle. Okay, so she is, well, first we can do the triangle, so looking down. Okay, and then you can draw another line here that represents water, and the cliff's just there. So we can see we have a right angle triangle, but you need to be very careful because the angle of depression, a lot of you on the test put 12 degrees in here, and that was completely wrong. If you remember learning this in class, when working with angle of depression or elevation, you start with a horizontal line. So when starting point is looking straight ahead. There we go. That's looking straight ahead. And then that means when she then looks down, the angle of depression is here. 12 degrees is actually in there. Okay? And you can see there's our right angle triangle, which is just here, that we've drawn in our diagram. 12 degrees is not in our right angle triangle. Now, there's two ways to approach this. Some of you prefer to say, okay, well, I can just draw another triangle above that one. They're identical, okay, just the opposite. And then I can work with that triangle above there. Or some of you prefer to use your knowledge of alternate angles. So if it's 12 degrees here, it's also going to be 12 degrees down there. Okay? Either triangle you want to use will work for other questions later on. But just remember that angle of depression, you first start with a horizontal line. So if you had a diagram similar to this, and we forgot to label here, it's 95 meters. Sorry, put in our lengths that are given to us. Then, yeah, you can't go wrong. Okay, so now using our diagram, let's work out question B. And it says, find the distance of the boat from the base of the cliff. Correct to 2 decimal places. Okay, so there's our boat. So the base of the cliff is just over here. And the distance from there to there is what we're trying to find. From the cliff to the boat. And now let's label that as, we can call it X if you want to. Or any other variable is fine. Okay, I'm going to use the triangle down here. So let's work out what trigonometric ratio I need to use. So I've got opposite, which is 95 degrees. I have then the adjacent, which is the unknown side I'm trying to find. So O and A, I know TOA is O and A. So I'm using tan. So I'm going to write my formula. Tan is equal to opposite over adjacent. And let's put in the values we have. The angle is given to us. The angle is 12 degrees. Is equal to opposite, which is 95 over X. And we can see X is on the bottom. Now, to solve this equation, you can go multiply X on both sides and then divide. But the shortcut, if you remember, is just switch the tan and the X. Okay, so we end up with X is equal to 95 degrees over or divided by tan and then 12 degrees in there. Okay, now all you're going to do is enter this into your calculator. The 95 divided by tan. Please make sure you use brackets when around the 12 degrees. And we end up with X is equal to 446.94 meters. The question asks us to the nearest second decimal place. So I'll put approximately. Now, because we're doing an application, please write your final answer as a statement. So therefore, we found the, and go back to the question to word it. Therefore, the distance from the base of the cliff, from the boat to the base of the cliff is, you can write that in later, is, and then 446.94 meters. Okay, so you should have had the final statement. Okay, for our next section, our next part C, It says she notices the swimmer 2 kilometers away from the base of the cliff, in line with the boat. And then what is the angle of depression to the swimmer, to the nearest degree? Okay, so once again, we have to redraw a diagram. Okay, and so over here, I have drawn what we found before. So there's my cliff, 95 meters. I have found from this point to that point to the boat, the cliff to the boat is 446.94 meters. And it says that she notices a swimmer 2 kilometers away from the base of the cliff, but in line with the boat. So where would 2 kilometers be? Now remember, we are suddenly using different units. So 2 kilometers is equal to how many meters? It's equal to 2,000 meters. So straight away, if the boat is over here, and from the base of the cliff, it's 446.94 meters, which is closer to the cliff, that means this swimmer is further out. Just say she might be, to try and do it a bit to scale, she might be out here. Okay, roughly 2,000 meters is over there. Okay, so just to make things a bit more simple, I'm going to get rid of this line here because we don't actually need it for this next step. So we know that the boat is over here. We've got our cliff, and now our new triangle we're trying to work with is going to be a larger one, I guess, because the swimmer is further out. Okay, there's our boat. So from here to here, we know it's 446.94 meters. And now we've got to work out the angle of depression. Let's just go back to the question. What is the angle of depression to the swimmer to the nearest degree? Okay, so we are still using, that person is still up on the cliff here and she's looking down. So there, but remember, angle of depression, we start with the horizontal line. So she's looking straight ahead first, looks down to the swimmer. There's our angle of depression that we have to find. Now, if it helps, you can draw another triangle up here, right angle triangle. There we go. And you can use either one. But I know that this angle here is also going to be just there as well. So I might just use the triangle on the bottom. And the other thing I've got to put in, the other length is from the base of the cliff to the swimmer, it is 2,000 meters. So change our units to meters. It's very important. So I'm going to find the angle of depression now. So here's my angle here, because I know it's equal to the angle up there. All right, so once again, I have opposite, which is 95, and I'm working with adjacent, which happens to be 2,000 meters. We can ignore that 446.94 meters for now. Okay, so the trigonometric ratio I'll be using, it's adjacent, once again is tan. So opposite over adjacent. Label what we have. We're trying to find the angle. So the angle will be our unknown. And we then have opposite, so 95 over 2,000 meters. Just write 2,000. Then use our inverse. So inverse of tan. And then in brackets we have 95 over 2,000. Put that into our calculator and it will give us the angle. Calculator gives us 2.7195 and so on. The question says to the nearest degree, so round it off. I've got 2.7. Because 7 is 5 or more, I'll add a 1 to that too, so I round up to 3 degrees. So the angle of depression is 3 degrees from the person looking down. And the last bit for this question, D, how far away is the boat from the swimmer? Correct to the nearest meter. So if we go to our diagram, this is why diagrams are very important. So how far away is the boat? Oop, 1 second. So we are trying to find how far away is the boat from the swimmer. So the boat's located here and the swimmer's over here. We are trying to find the distance between them from there to there. And to work that out, we have enough information to work it out. If I know from here to here is 446.94 meters, and then the longer length is 2,000 meters, all I have to do is go, okay, well, this will equal to 2,000 subtract 446.94 meters, And that will leave me with my answer. But it also, so I end up with 1,553.06 meters. To the nearest meter, it's just going to be 1,553 meters. We can call it D for distance, or you can write your final statement, but you should have had that. Okay, so the last question on the test was a very tricky question, and not many of you got this one right, which is okay because it was tricky. So let's go through it. A bricklayer supports a vertical wall using a piece of timber positioned to touch the ground 10 meters from the wall. So there's our 10 meters. A vertical metal support, there it is, 3 meters long, is placed under the timber support 6 meters from the wall, as shown below. And this is a good question because they've actually given us a diagram to start off with, which is great. And A says, find how far the timber reaches up the wall. So we want to find this side length here, from there to there. Okay, so once again, quickly brainstorm what we can do. What lengths can we immediately find? That might be useful, so let's have a look and see. Well, if I've got 6 meters from here to here, and this length here is 10, that means I can find this length here. 10 minus 6 leaves me with 4 meters. So straight away, I know that length there is just 4 meters. The other thing I can do, so right angle triangles are given to us. Label unknown side lengths using variables. And then the most important thing, are we going to use our knowledge of Pythagoras, trigonometry, or similar triangles? Okay, I'm going to call, so for question A, we want to find that side length. How far does this timber here reach up the wall? I'm going to call it X. Okay, so we're trying to find X. Now, I look at this diagram, I don't see angles, so most likely I can't use trigonometry. Pythagoras, yes, there are right angle triangles given to us, but to find this length here, can I use Pythagoras? It won't work. We don't have enough information. If I was given this length here, the length of the timber, then yes, I could use Pythagoras, but I don't have that. So it comes down to now our knowledge of similar triangles. We have to use our knowledge of that. So the next step is, when using similar triangles, is to identify the two different triangles we have that we're comparing. So what I've done from the diagram, I've separated the two triangles in that diagram. So this 3 meters was that metal pole there. And then we've got the 4 meters that we found. That was a smaller triangle. And then we've got the bigger triangle where it's the whole length here is 10 meters. And then we've got to find that unknown length here, which is question A. We're trying to find that X. We called it X. Okay, they are both right angle triangles, and we know they are both similar. If you remember learning similar triangles, they all have the same, all the angles are equal in this triangle. And in both triangles, that's why they are similar. If you remember, if you ever have a diagram like this, and I draw, sorry, excuse that. And if I put a line in here, I have made two triangles. There's a smaller one just here, but there's also a larger one over there. Okay, sorry, it disappeared. So that's what I've done here. When you've got two triangles like that, they will always be similar. Or even if I put more lines in, so one there, okay? I've actually got one triangle there, 2, 3, 4 triangles in that diagram now. They are all similar because they all have the same angles. All right, so back to our question. So similar triangles, we can now find the scale factor to find what X is. So if you remember, the scale factor, the formula we use is length over the original length. Now this one here is going to be our original triangle because we are trying to find this one here, X. So we can see it's getting smaller to larger. So our scale factor should be larger than 1. All right, the scale factor is equal to length. Now I'm going to focus on these sides here. these corresponding sides, 4 and 10 meters, because I have them. So length, but the original one is going to be 4, so I have 10 on top divided by 4. So my scale factor, I think before I said we're getting smaller, we're actually getting larger, so the scale factor should be greater than 1. So 10 divided by 4 leaves me with 2.5. And I'm going to now use this to work out what x is. If I know what length corresponds to this x, I know it's 3 here. So if I just go 3, this length here, times that 2.5, that scale factor, it's going to tell me what x is. 3 times 2.5 leaves me with 7.5 meters. So x is actually 7.5 meters. So write your final statement, and we have found that using similar triangles. Now, before we move on to our next question, I've just redrawn the diagram to see what we've actually found. So I've got my 7.5 meters here, the length from here to here, and I've found that. Now, with the next question, we have to actually find the length of this timber. Okay, it doesn't actually ask us that specifically, but we need that length. So I'm going to find it now, because I now know that this here is 7.5 and down here is 10. I can simply use Pythagoras to find out, okay, what is the length of this timber here? And that might be useful. So sometimes you might actually find an extra thing in case you need it later. So using Pythagoras, c squared is equal to a squared plus b squared. And that's c, my unknown side length there, the timber, the length of the timber. So c squared is equal to, a can be 7.5 and b can be 10. So 7.5 squared plus 10 squared. That will give me 156.25. Okay, so just saving some working out, some space. And then I've got to square root that. So c will be equal to the square root of 156.25. So c equals 12.5 meters. Okay, so the length of the timber here is 12.5 meters. Okay, and now I'm going to move on to question B, because I need that 12.5 meters to work out B. So B says the vertical metal support is moved so that the timber is able to reach 1 meter higher up the wall. How far from the wall does the piece of timber touch the ground now? To 2 decimal places. So this is actually tricky, but we've already started it. So for B, we need to redraw a diagram because our timber has moved, which means we have some side lengths that are different now. So if I redraw it, there's my wall, still there. There's my piece of timber. The piece of timber doesn't change its length, so it's always going to be 12.5 meters that we found before. That can't change. It's just a piece of timber. But now this metal support here, 3, has been maybe moved closer to this one, closer to the left. So this is gone higher up the wall. So I'll do my base down there. So I still have right angle triangles. And this length here, it says, is now, or the timber touches 1 meter higher above the wall. So what's 7.5? Because before we had 7.5 plus 1 meter. So now it's going to be a length of 8.5 meters from here to here. By moving this a bit closer this way, we tilt the timber up a bit higher, and the question told us by 1 meter. So you should have had 8.5 meters now here instead of 7.5. That means that this length here has now changed. It is no longer 10 meters. It has now changed to something else. And that is what we have to find for B. It says, how far from the wall does the piece of timber touch the ground now? So we can call that X if you want to. That's what we have to try and find. And we can just use Pythagoras. We've got these two side lengths here, 12.5 and 8.5. There's my right angle triangle, the larger one that I'm focusing on. And that will give me my side length. Sorry. All right. So simply use Pythagoras. C is my hypotenuse. I can call this A. If you want to call, instead of X, let's just call it B actually, because it's in our theorem. And off we go. So C squared is equal to A squared plus B squared. So substitute our values. We have 12.5 squared is equal to 8.5 squared plus b squared. Okay, now we just solve for b. You can rewrite it if you want to, or I might just subtract it straight away. So b squared will be equal to 12.5 squared minus 8.5 squared. So the more you practice working with Pythagoras' theorem, you can actually just do quick shortcuts and not have to rearrange anything. All right, let's subtract this. So we end up with b squared is equal to 84, is what we end up with. Square root that, so b is equal to the square root of 84. We can see we have a third, and the question asks us to round it off to 2 decimal places. So b is approximately going to be 9.17 meters. Okay, so that means, just to show it in our diagram, we have found the new distance from here to here, which is 9.17 meters. The length here has gotten smaller. Before it was 10 meters, and it makes sense. If this metal rod here started off here and went a bit closer and came there, okay, this means the timber here has tilted more, okay? If it's tilted more, then the length is going to get shorter on the bottom. And finally, for the last question C, let's just go to the question. It says, how far from the wall is the metal support now to 1 decimal place? So once again, redraw your diagram. We've got a new diagram now. The height the timber reaches is 8.5 meters. The base length is 9.17 meters. We found that. We know that the rod won't change its length. That's always going to be 3 meters. As well as that timber length, that's also going to always be 12.5 meters. And that's what we have so far. All right, so now to find so how far from the wall is the metal support now? So we want to find from here to there, we can call that X. That's what we are trying to find. Now, once again, to find that length, what can I do? Just brainstorm. Okay, to find that length from here to here, if I know the longer length is 9.17 meters, and I want to find this length, if I can perhaps